ratio test. If you have a series of positive terms and you take the quotient of the limit as n goes to infinity of the next term divided by the term you're at, and that converges, meaning goes to a number, then the series converges. If that series converges, or if that limit diverges, then the whole thing diverges. Anyway, if you run that infinite limit and that limit goes to something bigger than 1, then the series diverges. But if the limit of the quotient of those two sequences is 1, the test fails, and you got to try something different. Let's try it on this guy. Boom. What are we doing? We're doing the ratio test. The ratio test on this guy, n times 2/3 to the n power. We want to see if that guy's going to converge. So we take the limit as n goes to infinity of n plus 1 divided by an. And what would that look like? It's the nth plus 1 term of the sequence. So everywhere I saw an n, I put in n plus 1. Well, this thing should slow down any time here. Okay, what am I doing? Everywhere I saw an n in the original one, here and here, if I'm looking for the nth plus 1 term, I put an n plus 1 here and an n plus 1 here. And then that bottom one, that was an. That's this business down here. That's what we started with. And then we reduce. We see that we do some algebra. And then, yeah, it reduces down to that. But what? Oh, we're going to actually run that limit. 2/3 is a positive number. I took it out. The limit of n plus 1 over n to the 2/3, that goes to 1. So you're left with 2/3, which means that limit exists and that limit is smaller than 1. So by the ratio test, the original series converges.